Welcome to STEM Nola. My name is Dr. Calvin Mackie, and I'm happy to have you all tuning in. As a little background, we founded STEM Nola 7 years ago to expose and inspire and engage communities in science, technology, engineering, and mathematics. In the last 7 years, we've engaged over 50,000 K-12 students, over 12,000 families, and over 1,500 college students and STEM professionals. One thing that I'm proud to say is that we've put over $1 million in the hands of college students over the last 7 years serving as college interns with STEM Nola, going out and engaging the community. So thank you for tuning in. Parents, thank you for believing in STEM Nola and trusting us with your most prized possession, your child, your scholar. STEM Nola believe that either we're training ourselves from the neck up or the neck down. In the 21st century, our children will only have one or three options. Either they're gonna take something, break something, and/or make something. And if we don't give them the skills and education to make something, like make a living, make a life, make a difference, it only leaves them with the two options that we see on the news every night, and that's to take and break. I don't want that for my two children, and I know you don't want that for yours, and that's why we're here today to expose our children to the possibilities of the 21st century. This is my friend. This is Alpha. Alpha is a humanoid. A humanoid is a robot that tries to act like a human. This humanoid has 9 servos and can do pretty much anything physically that a human can do. This is our competitor in the 21st century. Alpha can actually do push-ups. Alpha can even show off. And Alpha can even dance. And like any superhero, Alpha has her own music. This is the machine. And the automatic machine in the 21st century will displace many workers. In the aftermath of COVID, you have to believe that there are many companies out there saying never again will we allow a pandemic or something that happened in nature shut us down. So COVID has exacerbated the possibilities of machines displacing people. If you're competing against Alpha, you will not win. The only way we defeat Alpha is by developing our heart and developing our head, training ourselves from the neck up such that we can control the robots so that the robots will not control us. That's why we're here. That's why STEM Nola exists. That's why your parents want to make sure that you all participate in events like this so you can know the possibilities of the 21st century. Again, I'm Dr. Calvin Mackie, and I want to say thank you for tuning in. Now let's get busy innovating, creating, and making with STEM Nola. Thank you.
Hello, everybody. Hi. Real quick, my name is Griffin. I'm a student at the University of New Orleans. And before we get started, we have a special guest who wants to talk to you about today's topic, which is structures and engineering. We're going to be talking about that. And like I said, we have a special guest from Boeing, whose name is Carson Kennedy, and he's going to tell you a little bit about that topic. So here we go.
All right. Thank you very much. I am very happy to be here. It's exciting to be able to talk about structures. This is what I do each day. And so I'm very honored to have the opportunity to share with you about what I do. And overall, I'll give you an introduction into what structures are. So who am I and why am I here today? So my name is Carson Kennedy. I was born in Huntsville, Alabama, which is called Rocket City. You've never heard of it. It's where a lot of our rockets are designed and made, from Apollo all the way through to the Space Launch System that I work on today. I attended the University of Alabama in Huntsville, where I got a bachelor's degree in aerospace engineering, which has opened up a bunch of cool opportunities. Aerospace engineering is a really neat field. There's a lot of things from flying to planes to rockets to anything liberating you from gravity that you get to study and you get to learn about and do whenever you get a degree in aerospace engineering. What I do for a living is I do design or structural design engineering for Boeing on the program called the Space Launch System, which is NASA's next big rocket that will be taking humanity to the moon and eventually be taking us to Mars. And on top of the Space Launch System, there's a second stage called the upper stage, and that's really most of my structural design work. And we'll talk a little bit more about what that means as we go forward. And that's the main thing we're going to be talking about today is structures. So if we got to first ask a question on what is a structure, all right? So we're here talking about structures. What exactly is a structure? So the definition of structure is a building or other object constructed from several parts, all right? Now you see structures all around you. If you are sitting down right now, then you're likely to be sitting on a structure. That chair is made up of multiple different pieces. If you're riding in a car, that car is made up of multiple different components and is structural. There are structural components of that car. And you can see on the slides that there are multiple different examples throughout history as well as throughout the world and some of the famous structures that you may be familiar with. You saw the Eiffel Tower right before this picture. This is the Colosseum. We've been designing and building structures for millennia. All right. Pretty much all of you are probably familiar with the White House. The White House is a structure. It has several different components and wood and concrete and all sorts of different come together to form what we see as the White House. All right, so you may have seen these pyramids before. These pyramids were designed thousands of years ago. And so in the study of structures was really been going on for thousands of years. And you see they were able to create these massive structures and able to figure out what they needed to do, what type of materials they needed to use, how big the rocks needed to be, the stones needed to be to lay the foundations for these pyramids. And they've stood the test of time. And that's what good structural design will do, is it'll stand the test of time and it'll support whatever load, which we'll talk about here in a second, or other environments that it is in. If you go to the next. And then here's my favorite picture out of these structures. Go back right quick. Picture, you'll see the rocket, right? There's a bunch of structural components within the rocket itself. And then the stand that you see behind it is also purely structural. There's a lot of structure too. Whenever we think about rockets, you have propulsion, you have your avionics, which controls which direction it flies. And structure helps kind of tie all of that together and lead to the propulsion being able to lift the rocket or lift the vehicle up into the air. So if you go to the next slide, we'll get a little into details on what you consider when you're thinking about structural design. And so what I want us to do is I want us to do a little, experiment, you can say. And you see this beam that goes across these 2 points on your screen. And what I want you to imagine is that someone has asked you to design a bridge to support a vehicle driving across the bridge. You might think, well, how on earth do I know how to design the bridge? How thick do I make the bridge? How wide should I make the bridge? How far apart should I put supports that are on the bridge? All these are questions you might start asking. Are there different shapes that I can make the bridge? And these are all valid things that as a structural design engineer, these are things I think about on a daily basis. What are the different ways that I can design this bridge in order to support that vehicle? And so if this vehicle gets halfway across the bridge and stops there for a second, the bridge will actually start deforming and start bending under the weight of that vehicle. Now, you might never notice this, and it can be a little scary to think about whenever you're driving across a bridge next time. But every material deforms a little bit whenever a load's applied to it. One of the best ways to think about this is you have like a straw, right? And you put a straw between two fingers and you press down in the middle of the straw. That straw bends as you put a force down into the middle of the straw. So what is the main thing then as a design engineer or as a structural engineer that you have to consider whenever you start looking at these forces that are applied on these structures? And the question you got to ask is, well, will this structure survive? And how do you know if that structure will survive? Well, you start looking at what we call stress and strain. All right. So when I put the force, if you look at the middle of that second image, when I put that force or that vehicle down in the middle of that beam, the bottom portion of that beam goes under tension. So it's kind of stretched a little bit. And the top portion of that beam goes under compression. All right. And another way, again, you can visualize that by take a straw, put it between two fingers and press down in the middle of it. You'll notice that the bottom part is what stretches, whereas the top part kind of compresses on itself. All right. And so what we look at is when we put that force on that beam, we analyze the stress and the strain that beam sees. So what is stress and strain? So the definitions are on the bottom of the slides. Stress is the pressure or tension exerted on a material object. And then the strain is a force that tends to pull or stretch something to an extreme or damaging degree. And one of the easiest ways to think about stress is in your own life. A lot of times, whenever schoolwork gets complicated, whenever you got a bunch of things on your plate, whenever you have a lot of chores to do, your parents may be on you, or you get loaded down, right? You have a lot of load on you, a lot on your plate. And so what do people say? They say they get stressed, right? That pressure or that tension is being exerted on you and it's a little bit different since this is that's more of a psychological stress, but it's a very similar thing that materials see. A material can only handle so much stress or strain before it breaks. And similarly, like we can only handle so much before we eventually break, right? So that load back to the beam or that bridge that you're designing, when that car is sitting on it, you can do a stress analysis, which we won't get into the full range of stress analysis in this tutorial or this introduction to structures, but you can do an analysis to see how much stress that vehicle puts on your bridge. And then every material has certain limits and has certain limitations to which it can handle a certain amount of stress. And so you analyze, see, okay, well, this vehicle puts X amount of stress, pounds per square inch, onto this bridge, and the material can hold, a larger amount of pounds per square inch. Then you're good. So whenever you see that your material can hold or handle more stress than what your force puts on it, then your bridge or your structure will survive. But sometimes it's not the case, and your bridge cannot support the weight of that car. And that's really where structural engineering gets fun, because you start thinking of how you can use different shapes like triangles, or use different ways to transfer the load, or use maybe different materials that are stronger, can handle more stress. And all of those things are things you think about whenever you're doing structural design. But it all boils down to that simple thought of, I have a structure, I apply a force, just like your vehicle on that bridge, I apply that force. And how much stress and strain does that force exert into the material? I hope that you've enjoyed learning a little bit more about structures and how structures are used throughout daily life, from the White House to rockets to a variety of different things. And maybe this will probe you to want to learn more about the fun and never-ending knowledge of structural design. Thank you for your time, and I look forward to seeing what you're going to do in the future. All right.
All right. Well, thank you very much, Carson. Sorry. All right. Thank you very much, Carson. That was awesome. That was a great wealth of information for an introduction. I personally learned a lot too. So we are about to go ahead and get started. I am excited about it. It's definitely going to be a challenge for today, but I think that we are up to the challenge. So, and thank you so much, JV. And I am happy to see you. Thank you. Welcome. I feel welcome. All right, here we go. So this is the agenda for today. So we have our vocabulary terms that we're going to go over. We have our objectives, our activity questions, and then what we're going to do is go into the activity and we're going to build bridges. We're going to kind of test that out and see what is the best structure, what's the best shape, and how can we do that? How can we build a structure that's going to be able to hold up some weight? Then we're going to build a roller coaster. And then we are going to go ahead and get into our activity questions. Again, we're going to test your knowledge on all those vocabulary terms and information that we talked about and applied in our activity. So I hope you're ready to get started, because we got a lot we're going to do and it's going to be fun. So, all right, first order of business is to go over those vocabulary terms. So just like Mr. Carson was telling us about, we talked about stability, base, weight, and load. Those are very important terms when talking about structures and talking about engineering. So stability is the resistance offered by a structure to undesirable movement like sliding, collapsing, or overturning. You want something that's stable, right? You want something that's sturdy, that's going to be able to hold up that weight. When we have a bridge, there's a lot of weight. There's tons and tons and tons of weight. We want it to be stable. Then when you have your base, which is the bottom of something. So when you think of kind of that bridge you see right there in the picture, you've got that road, you've got that concrete base that should be really, really sturdy, but you also have structures underneath holding up that base. And it's the bottom of something that is considered the support or the foundation. You have weight, which is the object or the force acting on it due to gravity. So you can think about a car or even people, different things. A bird can apply weight, but it's not going to do much to a bridge, hopefully, if it's strong. But you have weight like that, and then you have load. That's forces that act on the structure, such as the weight that they bear. And it can be other things too. So for instance, a colleague of mine told me, if you're jumping on a trampoline, you have to think about when you're designing it, how much do I weigh as a person? And then how much force am I applying on that trampoline? You have to take all that into consideration. So load is not only just the weight, but load can also be the amount of force, the acceleration, how much force are you putting down on something? So we're going to talk about these terms again. Remember stability, base, weight, and load, and we're going to apply that in our activities. So, all right, we're going to go over the objectives real quick, and that is going to be you being able to understand the meaning of stability, base, weight, and load, and apply them to our activities, as you can see in the picture. And then you're going to learn how to build a bridge. So hope you're ready. And we have those questions for you really quick too. So what shape can support more weight in the bridge? Flat or folded? Which one do you think? If I have a flat one or if I have some fold in it, some ridges? And then who is responsible for designing bridges and roller coasters and making sure they are safe? Who are the people that actually build these things? And then what 3 things do engineers and architects look for when designing a roller coaster? So that may have not been totally mentioned yet, but we're going to talk about it. So I hope you're ready. Let's get started. All right, we are going to first order of business, build a bridge. This one's going to be kind of like an experiment. We're going to test out different things first. So I'm going to let you get your supplies, and then we're going to talk about kind of the science behind everything. All right, so materials that you will need, that's 3 sheets of paper, and you can use construction paper, you can use copy paper, you can maybe use newspaper. You want something kind of sturdy, you can use cardstock, whatever you have, but today I'm going to be using construction paper. And then you need some tape. You need books or wooden blocks. I had my friends here take some foam blocks and tape them together. So you could even use like Legos. You could use wooden blocks. You could use cereal boxes, whatever you're feeling. You just need something that's going to be able to kind of act as your sides for your structure so that you can have your bridge. And then you are going to want some toys or coins. I've got some interesting farm animals, and I've got these heavy coins. So if you don't have maybe this, you can use pencils, you can use rocks from outside or something, just something, that's kind of light in weight, and then something a little bit heavier, not anything too crazy. We don't want to use, I don't know, a tire, a hot glue gun. We don't want to get crazy with it. So I'll give you time to get those materials for right now. And then I'm going to talk about the science behind it. So engineers have to think about many things when they design bridges. They have to choose a really strong material that's also weather resistant because, as we live in New Orleans, we get rain, we get wind like we just saw the other day. We get all kinds of weather. So it needs to be able to withstand that. It needs to be able to be powerful enough to be able to take all that. And then the materials also need to be shaped in a way that makes them really, really strong. So we have something like a zigzag fold. And if you think about a zigzag fold, it makes this shape. Well, kind of in it. And what's that? A triangle. So a triangle is a really, really strong shape. And then we're going to see if a triangle is stronger or a square is stronger. And then you need, yes, triangles are really strong, but do you know why they're really strong? It is because they have a large base. So it has a point, and you wouldn't think maybe that's a strong structure, but it's got this really long base. And you'll see why triangles kind of are able to hold more weight. So hopefully you have all of your materials together. And if you don't, that is okay. You still have a little bit of time, but we're going to go ahead and get started. I'm going to prep my materials. And like I said, if you're still maybe getting rocks from outside, not getting tires or anything crazy heavy, that's okay. Take your time. I'm going to get started. So thankfully, I've got my side structures kind of already built. Like I said, you can use maybe cereal boxes. You can use, anything that you want. It can be super high like these big boxes, or it can be a little bit smaller. But try to, just keep it simple. Alrighty. And so we're going to use 3 different sheets for this one. And I'm going to use 3 different colors just to tell mine apart because we're going to make 3 different bridges. All right. So I'll move that out of the way for now. I have to design my bridges first. So the key is, or the goal is, like I said, these are going to be the sides, and then I'm going to have to make kind of that foundation, something that's going to be my bridge to hold the weight. So that's what we're going to do. And it's not too hard. These aren't really that tough, but I will get started with my first one. So I'm going to use green. And you don't have to use different colors, but I just choose to, different colors for different types of bridges. So the first bridge we're going to make is something called a trifold. It's just going to be a flat surface, but you're going to basically fold the paper into 3 parts. So this would be half, just cutting it in half like this. But I'm going to fold it into 3 separate places. So maybe, all right. Get a nice good crease on it. And this is why you want tape too. I'll show you. You're going to fold it over twice. So again, it's going to have like this 3-piece shape. So when it's just a regular paper like that, you don't fold it all the way over like a book, but you just kind of, let me take this. You kind of go, not so much in the middle, but where you get a piece that looks like a nice good rectangle, nice size. So you fold that over and then you just fold it over again. And if you feel like you see you have some space, just kind of push it over. And then make sure you crease those sides really good because you want it nice and flat like this. Trifold. And then what you're going to do is you're going to tape both the sides so that you kind of seal it and it's not going to puff up or open up. So you can flatten it as much as you want. Try to remember, make sure you flatten it, get those nice good creases. And then you're going to seal it. And however you tape it, it's up to you. I kind of put my tape flat and taped it on the sides. And you don't have to use a lot of tape. You can kind of fold it over like this, or you can fold it from the sides, however you want. So that's my first one. That's a flat one. Now I'm going to make my second bridge. Here we go. Right. And this one is going to be very similar to what we just did, except we're going to fold it into 4 creases. All right. So I'll show you what I mean. Please excuse me if it's not perfectly in 4, but we will get it. I think we will get it. Okay. So I have a little wiggle room. So I'm going to. So when you open it, you should see 4 that are almost, the same size. All right. So just like that. And then remember, same thing. You want to smush it down, smash it so it's nice and flat, not crumpling it. Just making sure those creases nice and crispy. And then you got it. So you're going to tape the sides again. I'm just using one big long piece of tape. And then I put it on the side and I just kind of fold it over. Nice little sandwich and bam, bam. Turkey and ham. It is good. So, all right. Same thing on this side. And I've got my flat bridge. So if you even want to write on it, I'll write that this one is my 3-fold. This one is my 4-fold. Just meaning that I folded it 4 times. And this one, I folded it 3 times. And it's also flat, as I know, flat. And then this one is the one that gets interesting. I made it my favorite color because I like the design for this. It looks crazy. So this one, you kind of fold it. Well, you do fold it, but it's different. You almost fold it like you're making an accordion. And if you know what an accordion is, you kind of have this crinkled paper almost, and then you stretch it out and you see all these little zigzags. And I'll show you what I mean. So you take it, and we're not going to fold it as much as we did the first time. We're just going to take a little piece, bend it. And then instead of going forward, you're going to flip it over. So where that fold is now on the back. And then you are going to do what you just did, fold it again, same size. And then you're going to keep doing that like an accordion. All right. And then you get a little accordion. All right, that's what you should want. And then this one for sure, we're not taping this one. So just kind of smash it down, flatten it out, get those ridges, play your accordion. Yes, I'm so sorry. So this is kind of that accordion thing that I was talking about. So how you do that, I'll use this piece of paper to show you. Again, you start out with a flat paper. And then what you're going to do is you are going to just fold a little piece over. So you see, I'm not folding a lot of it. I'm just folding a little bit. So I'm going to fold it like this. See, it's just a little bit. That's maybe about like, what, an inch, 2 inches of a fold. And then I smush it. So I have my flap up here. And then when I get that fold, I'm going to flip it over to where my fold is now facing a table. And I'm going to fold it the exact same way I just did. Get in that same shape. So now it's going to kind of puff up like this. It should puff up to where it's got this bounce. It should look like this so far. Does that make sense? So, all right. And then you're going to keep doing the same thing. You're going to take it and then flip it over. And then you are going to fold it again. All right. And keep creasing it. So you fold and you flip. And then you flip and you fold. And then you should have that accordion, but we're going to call it zigzag. So this is the zigzag style. All righty. Looks like it can hold tacos, like those little taco trays. Okay, there we go. So you got your little zigzag piece. So now you don't have to write on it, like I said, but I'm going to write zigzag. All right, so now I have my 3 different bridges. And like I said, we're not going to tape this one. All righty. And then now is the time that we are going to test. So you can go ahead and get your side pieces that you have. All right. Like I said, I have these foam blocks and they're taped together. They're kind of tall, maybe like 9 inches tall, I'm thinking. But if yours is really tall, that's okay too. It can be tall like these boxes you see here. As long as your pieces are the same size and the same height, that's fine. That's what you want. So we got to kind of configure it and build our bridge first. So the first thing we're going to test is our 3-fold flat bridge. Okay. So we don't want it to be super close together because that's kind of cheating. If we put something on it, it's really hanging off this. What we want is we want this to be the strong foundation. We want to see how strong this is. All right. So we're going to push these apart to where our bridge, well, it kind of, looks like a bridge where I'm trying to walk over here. So we'll just put it just enough to where it's kind of hanging up on the sides, but you want the majority of this piece to be over your table. You won't want anything to be underneath here, which would not be maybe the best bridge. It just depends on how strong this is. So I'm going to get my materials out, and I've got some fun farm animals and some heavy coins. So what I'm going to do is I'm going to start with something pretty light. I think my trees are pretty, well, my little chicken pieces, they're pretty light. I'm going to put my little chickens on here and I'm going to see. So far, so good. We're doing okay. So you can put your materials on. Like I said, start with something pretty light. You don't want to go straight heavy. I don't want to get these pennies, which are really, really heavy. And then I have my little lamb. Oh my gosh. Well, that was my fault. I pushed my bridge. So we know that's not super sturdy. So let me make sure that I don't touch these sides. So I'll put my chickens back. All right. And then I'm going to put a little lamb. And so far, so good. I'm going to put a tree. Let's see if I can put the horse. We're still hanging in there just enough. But do you think that we can make it if I put a cow? We shall see. No. So my bridge fell. It wasn't that sturdy. And I didn't think it was going to be that sturdy because it's paper, but we tried to give it some weight, make it a little bit sturdy, but it's flat. There wasn't much underneath it. It didn't hold up, but it did hold up a few things that was pretty light. So now we're going to try the fourfold flat, which is a little bit more, so that's a little bit different. All right. So, but also that is a good point. So when I put something heavy like my cow and I start to put these things to go over it really quick, we have different materials. If I put my little chickens back up, if I put this horse, I don't know if it'll stop. So what happens is you can kind of see it, but I'll show you, like Mr. Carson was telling us, when we put something on here, we get that tension kind of in the middle. So I put something here and the weight starts to push it. And that's what causes it to collapse. It's that tension. This can't hold it. It's barely hanging on. Maybe if I had something on top, it can hold it and it can hold more tension. But when I put this here, there's not much that's able to support it. So then it starts to fall down and we get that tension. So the weight was too much and there was too much load acting on it. All right. And so now we are going to go to our fourfold flat now. That was a tongue twister. And we are going to test this one out. So this one feels a little bit thicker, but it's also not as wide. So what do you think is going to happen with this one? We shall see. So let's make sure that we get it up there. Oh gosh, if I can get it up there. All righty. So we'll test out I think I'll start out on a similar pattern and I'll start with my chickens. So what do you think? You think it's going to hold up or not? So we're safe with the chickens. All right. Decorated with my tree. I'm going to use a little pig this time. He's a little heavier than my friend the lamb, but so far so good. I think this is, yes, the lamb chop. The lamb chop. So we're doing good so far. But now I'm going to go to my horse. Woo! Cause my little animals to fall over. But you see, when I add my horse, so I'm going to lay my tree flat. I don't know if you can see it, but on my side, I got that tension where it's starting to kind of fold in the middle, where it's a little bit too much weight. So it's starting to kind of push about right here. But you can't see because the horse is in the way, but I got that little baby bend right here. All right. It's still holding up though. I'll put my pig. So far, so good. What do you think is going to happen when I put my cow? Oh, well, if yours is holding a lot, then yours is doing really good. Mine's holding a lot too. But what are you holding, Javian? Are you holding something heavy? Are you holding something light? My stuff's pretty light, but when I put my cow, so little bridge collapsed. He did good. He did good for a while. He held up way more than the threefold. I'll say that. But I'm glad that your bridge is holding up really, really well. So maybe you made yours a little bit sturdier. So maybe if I would have used cardstock or if I would have used a heavier piece of paper, maybe it would have held up more. But the fact that I used construction paper, I think that maybe that paper was a little bit too light. And so if I would have used something thicker, maybe like I said, cardstock, like a really thick paper, it would have held up better because it's heavier and it was a little more sturdy. So we want that stability. But now we're going to test out the zigzag one. So remember, get nice and crispy, fold it. All right. All right, so I have my little tray. Here we go. So this one's interesting. You may be wondering, how am I supposed to put stuff on it? Do I put stuff at the top? That's kind of up to you. It depends on the materials that you have. But since I have little farm animals, I'm going to put it in the creases. And like I was showing you and telling you, I've got those triangle. You see, if I had something at the bottom, it makes these triangle shapes. So we're going to test out and see if the triangle is a sturdier or a weaker shape if I put it on right. So let's see. All right, little piggy went to the market. This little piggy, he went I don't know where he went. He went somewhere. He's going someplace. All right, keep it light. My chickens. Get a tree. I'm gonna go a little crazy and put the cow. Okay, we're doing good so far. Doing all right. And lamb. Horse. Oh, my horse fell off. Maybe if oh my gosh. Okay. My poor little creature slid off. So my bridge is falling on that side. I made it kind of collapse. Let's see how much I can hold. That part of my bridge is kind of weak. How's your holding up? Hopefully it is good. My bridge is a little weak at the moment, but I think I can put a few more things. So this side's looking pretty good. Oh. Are you still on the first bridge?
This first one hasn't fallen yet.
Oh, your first one still hasn't fallen? Well, you are doing awesome, Javian. My first one fell with my farm animals. Mine wasn't that great. This one, I'm thinking maybe if I would have put it on the sides a bit better, maybe it would have held up more. Maybe I didn't put it on the sides good enough, but I think my middle part of the bridge as well, but I don't know that I would walk across this. It doesn't look super safe at the moment. Let me see if I can scoot it up a little bit. There we go. All right. So I've got a lot of stuff in the middle. I feel like I could just keep piling on with my farm animals. If I ever saw this in real life, I'd be very concerned with my farm animals. I don't know what is going on, but they're having a party. All righty. So my middle part is doing rather well. I haven't been able to hold up this much. And I'm just going to, okay. So this is great. The side, not so much, but my middle piece is doing pretty well. But it's kind of like cushioning. What's the word I'm looking for? It's got the side pieces on it. It didn't really have that. The other one was flat. And this one has, like I said, these ridges. It has these points that kind of cuff it in and kind of hold it in. Almost looks like a little couch too, but it's kind of keeping it enclosed. And so these creases, I think, give it a better hold, and they're able to hold more weight and absorb more tension, because I'm not really getting that fold in the middle. Javen, you are very impressive, because my bridge very much fell. So you were doing a great job, and mine just fell. But I think maybe because I pushed it. But look at all the stuff that I was able to hold. I was able to hold, let me see, 1, 2, 3, 4, 5 trees. I was able to hold 2 cows, 2 horses, 2 mama lambs, 2 baby lambs, 2 baby horses, and 2 pigs, and a lot of chickens. So I think I did pretty good. I'm pretty sure you're doing great, Javen, because you're still on yours. But even though you're still on yours, since you were able to do a really good 3-fold, maybe test out that 4-fold, and then also test out your zigzag structure, so you can kind of see maybe what's the best one if you can hold heavier stuff. So like I have something really heavy that I'm going to test out. I'm going to see if any of them can hold it. We'll see. So I'll kind of keep it on the sides like I did. I have this roll of pennies. And as we know, money can get pretty heavy. The more that we have, it can get, like I said, pretty heavy. I think this is $1. So I think that this is $1 worth of pennies. Could be wrong, but I'll just say that it is kind of heavy. It's got some weight. All righty. So you think it's going to hold? I didn't think it was going to hold, but it's pretty heavy. And my 3-fold little flat piece did not hold. The 4-fold one, like I said, it's a little bit thicker. Think it's going to hold? That did not hold. All right. Now I've got my 4-fold flat. Let me kind of crease it up a little bit more. All right. Palms away. No, it didn't work. It did not work the way I wanted it to. But that is okay. That's kind of the point. So we would need to do a lot more to be able to hold these pennies, right? We would need something a lot heavier. Obviously, if I were to put this on a real bridge, I think it'd be okay, just because, it can hold cars. But this is pretty heavy. If I put it on this box right here, it can hold it. The structure of it, this is a thicker cardboard material. So that's what we were talking about too. You need a material that's really powerful. Our paper, probably not the most powerful one. But maybe if we used multiple, if I, did this and I did it 3 times and stacked it on top of each other, maybe I would get what I need to get. So maybe I would get the bridge that I need. So,
The green one, the yellow with the blue on top.
okay. So I just got a suggestion that maybe we can try. So I think if I heard it right, maybe we should try the green, try the yellow, then try my foot. Let me see. I think I need to do it this way. Yeah, that's how I did it the first time. So maybe if I do it this way, I don't know. What do you think? What do you think, JB? You think it might hold if I put all my bridges on top of each other? You think we got a better shot? Oh, look at that. Okay. So got a little creative on that one. So maybe one of them, oh, goodness gracious, you can't roll it. You can't move it. If you move it just the slightest, it will fall. But we put all of them on top of each other and they worked. So thank you for that suggestion from my colleague. That was a pretty, I didn't think about doing that. But that is good. That was a better bridge, I would say. I think you'd probably hold all my farm animals and then also these little baby deer that I didn't use. But it held this, but you couldn't move it because once you started to move it, it's a different type of force that's applied. So that force, it starts to move, it has motion and it kind of gets heavier. But I think that this is a pretty successful experiment. So we realized, that we need the right material, we need the right build, we need to test it out and see how we're going to structure it. So I don't know if you were able to test your different ones, but I hope you did because we are about to move forward to building our roller coaster. So this one, we're going to apply kind of those things that we were talking about to the roller coaster. So this was, like I said, our science experiment to kind of test out and see, what material would be best. What's the best shape? How sturdy can it be? All right. So I'm going to move my farm animals out the way. I don't need them this time. I don't see pigs and cows on roller coasters. So, all righty. Here we go. So the roller coaster, similar materials. So hopefully you just have, an abundance or you have a lot of the stuff that you need. So we need more construction paper. This time like I said, you don't have to use construction paper. You can use copy paper. You can use newspaper. But remember, think about the structure. Think about the sturdiness of your material and think about how powerful it is. Can it hold some weight? Can it shape? Can it bend? Can it mold? Think about that. So you also need glue. You can use different forms. I'm going to use a stick glue. You can use regular wet glue, or you can even use hot glue. Hot glue may take a little bit longer and it's also hot, so it may take longer to kind of do the experiment that you want to do. So do whatever you feel is best. I'm going to use a glue stick. I think it might be a little easier and faster. And then you maybe want some markers to design your roller coaster. You don't have to. Use the markers if you don't want to, but the markers is kind of so you can put your rails on it, have your tracks and stuff, and decorate your roller coaster how you want. But really what we're mainly concerned about is the structure of it. So we're going to go ahead and move forward with the science. While I talk about that, just maybe get all your materials. Remember, you need construction paper, glue, scissors. Any kind of scissors is fine. And then you need also your markers. So the science behind it is architects and engineers. So I don't know if you've ever heard of those people before, but they are people that have to design and build the structures. Architects usually are the ones designing it, but they need to be familiar with how to build it in order to design a good structure. Then engineers, they were the ones responsible for kind of also designing, going in and building it. So they have to design and build structures that are safe for people. First, they design a roller coaster and they consider how safe it is. That's probably top priority. It is top priority. How stable it is and how fast it'll go. So the speed. So think about if I wanted to build a roller coaster, I want to make sure it's stable. I want to make sure that it can, be speedy. And then I want to make sure it's safe. So JB, and that is pretty impressive that you were still on your first bridge. What are you using? What materials are you using? And how did you build your bridge? Definitely, please take pictures because we want to see. Take a picture with all of the materials on top of it, kind of like you saw with mine. I want to see all that. So, and test out the different ones too. So you can take pictures of the different kinds of bridges that you used because we definitely want to see that. My first bridge was not great. When we put them all together, way better. But big Legos, I definitely want to see a picture of that. Please send us a picture because I'm very curious what it looks like and how many Legos you're able to put on it. So, all right, but also don't forget, we are going to go ahead and do our roller coaster too. So like I said, if you're still getting your materials and you want to keep your bridge next to you, that is perfectly fine. So you can have a bridge in order to get to your roller coaster. So like I was saying too, they begin thinking about the things that they're going to do. So the first step is how are they going to design? How are they going to design this bridge? What is it going to look like? So we've seen all kinds of different roller coasters before, but definitely stability is a big thing. Sometimes they do these weird spirals. They go side, they go upside down. Sometimes they're just kind of, smaller roller coasters for maybe smaller kids because you can't go super high, super fast. So you got to take all that into mind of how you're going to build your roller coaster. And then just like an engineer, you need to consider how safe, stable, and powerful it would be. When we talk about power, we want to make sure that it can hold a lot of weight, that it can be weather resistant. So if wind starts to come, if something hits it, can it hold that? Because as we saw with my bridge and our coins, when I hit something, it just kind of fell over and toppled. So it wasn't super stable. So what we're going to do is we are going to build a roller coaster. And you might be wondering how we're going to do that, but we are going to try. All right. So you need a base, and then you need, so I'm going to use this as my base, a green one. And then you need some different papers. And what you're going to do is you are just going to kind of cut out different pieces of how you think the roller coaster should look. So I'm going to cut out different strands. So just think about a simple roller coaster. What we really do, the main goal is we want to see if we can achieve a loop. So a loop, just kind of, let's see if I can create it with this one. You want to create a loop and be able to hold that up. So that's our main goal with this roller coaster. So we'll make something kind of simple, but if you want to make it more complex and build after we're done, definitely please show us and take pictures of all the kinds of roller coasters that you have built. So I'm going to cut out a few strips of paper. You cut different sizes. All right. I'm going to get some shorter pieces, and I have some long pieces. I'm going to have my really, really long pieces. Oops, that's okay. That's why we have multiple sheets of paper. All right, so what we're going to do is we're going to think about it. So usually I think about the roller coaster I had in mind was the one from City Park where the little ladybug roller coaster is. And I like that roller coaster a lot. It's kind of simple, but it's got this spiral on it, sort of. Well, no, it goes up and then it goes down. So that's kind of what I want. But I think I want to have a spiral in mind. So you got to think about how you want it to begin, how you want it to have that spiral, and then how you want it to end. So, and you can always cut your pieces or maybe make them longer. All right, so what I'm going to do is add a lot of glue. So feel free to add a lot of glue, and I'm going to paste it down. And what I want to do is I want to kind of curve mine. You can design yours any type of way, but I'm going to try to curve mine and then make it come up and loop and then come back down. So I just glued a little bit on here, just a little piece, and then I'm going to find another piece where I can kind of curve it. All right. I think that should probably might make it a little bit shorter. And if you have a piece that's too long or too short, like I said, you can either cut it to take away or you can maybe add to it with some glue. So I'm going to glue these pieces together. And if maybe you're like, man, how do I design a roller coaster? Don't, be afraid to ask an adult for help or ask a sibling, maybe your brother or sister. Like, what do you think? It's your opinion, because engineers and architects, they don't work alone. They need to work with other people, and they ask people, how can I build this? How can I make this better? I definitely asked the first time I tried to build because I was like, how am I going to build this? So far I've got this. So I'm going to start here and I'm going to curve. Sometimes roller coasters kind of go on the side and they curve, but I want it to go up and spiral. So I'm going to see if I can achieve this. All right. So I'm going to use a long piece. Actually, I'm going to use another short piece, and then I'm going to go to my long piece. So we're kind of testing it out. All right. All right. So when I think about it too, usually roller coasters have these structures and these wooden sticks or even steel beams, different things underneath to kind of hold them up. So you may maybe make yours without something underneath, or you maybe will make yours with nothing, something. I'm going to use a little bit of something to kind of hold it up so I can keep this curved the way I want it to. So and if you don't have all the supplies you need, that is A-okay. The main things, if you just are able to get something, you can look, if you don't have glue, you can use staples or you can use tape. You can use anything to kind of keep it sticking together. I use glue, but really the main thing that you need is paper. Any kind of paper will do. And then try to get something that's going to hold everything together. So like I said, if you have glue, staples, or tape. All right. So I'm going to kind of create something. So remember we were talking about that zigzag. That zigzag was really strong. It was a stronger structure if you were able to test it out because it had those triangle shapes. So for my beams, the things that are going to hold my roller coaster up in the air, this is going to be my bottom piece. Let me see if I can hold it like this. So the roller coaster is going to kind of curve and it's going to be above. And I'm going to use this little piece to kind of hold it up. It's going to go underneath and be able to hold this up. And in order to do that, I'm going to kind of zigzag it. Like I did where I have that little zigzag to kind of hold it up. And I'm going to see if that works maybe. All right. All right. And Miles, what supplies maybe are you missing? Are you missing paper or are you missing scissors or are you missing glue? Because maybe we can find something else that you can use. All right. Let's see. So I'm going to use this. I'm going to see if I can achieve it. All right. So if you don't have scissors, that's okay. You can always take paper and you can just kind of, a good way to use scissors without using scissors if you have paper is you can fold how big of a piece you want. So if I want a short piece, I'm going to kind of fold it. And then wherever I folded it, I'm going to rip it. So you can just rip it and you can still get what you need. And then if you don't have glue, do you have tape or do you maybe have a stapler? That's something I just kind of staple it together. Because if you have that, then you are good to go. So maybe see and ask your parents or ask somebody if you have tape or if you have glue. All right, so I'm going to see if I can achieve this loop. First, I'm going to kind of hold this down. So like I said, this is my little accordion piece. So I started here and I've got my little zigzag piece sticking up. That's what's going to hold up my structure. That's what's going to hold up my roller coaster. All right. Use a lot of glue. And like I said, if you don't have glue, tape would be really, really good. Tape might even work better. But glue kind of gives it more of a challenge. All right. So kind of hold it up a little bit the way I want it to. So now I'm going to try to achieve my loop. So the way you make a loop is you just take your paper and you hold it straight and you grab one side of it and you kind of go over half the way, you curve it, you make this C and you pull it apart and you just kind of pull it and you get this loop. You can make a really big one or you can make a smaller one. The size is up to you. So I'm going to kind of make a size maybe like this. But like I said, you just take the paper, take one side and you roll it over and voila, la. You have a little curve, a little spiral. So I'm going to make it like this. And how I'm going to do that is I'm going to keep gluing my pieces together. Or like I said, you can use tape, or if you have a stapler, you're going to staple every time those pieces of paper meet, you're going to staple them together. All right. Maybe you can use something really sticky. If you don't have that, maybe get some caramel candy and then you can melt it and you can use that. And that is crazy sticky. I wouldn't recommend it, but if you need to really get something sticky, there's an option. Like I said, I wouldn't recommend it, but all right, I have my spiral piece. So now I need to kind of connect it to another piece in order to keep it. So whoa, my structure's moving. I might have to fix it, but that's okay. We're in the modeling phase. We're just kind of designing it right now to see how it would look, how it would work. All right, so I think I can make it. So I'm going to take another piece and connect it to the end because, you know, once I go up, I need to come down to the right place, but I might need another piece to hold this up. So I think what I'm going to try to achieve is just this. We're going to see. I think I can make it work. How are y'all coming out with y'all's? Hopefully it is good. Hopefully. I feel like it probably is. All right. Based off the other pictures that we've seen, I think y'all are probably some engineers. So I think that engineers in the making, I think you can do it. All righty. So keep your spiral shape. Oh, I'm glad. Please. And like I said, please take pictures. We definitely want to see pictures of these roller coasters. My first one looked very interesting. So I'm trying to make this one a little bit better. So I'm going to glue the bottom down. Keeping that spiral, and you don't have to make a spiral. If you don't, it's okay. If you just want to maybe make something that kind of goes up and down, almost like a snake. You know what, Javian, thank you for being an awesome, awesome student. You're an awesome student. So I've got it down, but like now my spiral keeps folding. It keeps kind of folding over. So how do you think that I'd be able to hold it up? What should I do? I'm going to put something underneath this spiral, and I think that maybe I can get it to stay up. We're going to see. I'm going to try something a little bit different this time. Do it zigzag, but not fully. I'm going to make a Z for zigzag. So let's see if it works. Boom, 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 boom. Maybe. Let's try it. All right. So we are kind of coming to our close because I think that we spent a lot of time on our bridges, but it's okay because that was the experimenting part, and that's the part that I like. So this experiment or this activity doesn't have to end just because maybe we end our session, but almost got, oh, okay. There we go. There we go. I don't know if it's super stable, but I'm making it. So I got my spiral. And then what I would do to complete my roller coaster is kind of make this meet it. So this is an interesting roller coaster, but it is a roller coaster nonetheless. But like I said, I definitely, let me see if I can, yes. Want to see y'all, so please take a picture of it because I think that hot dog. So this one is a little rough, but nonetheless, it's a good little kid roller coaster. It gives them a taste of what it would be like to go upside down. So here you go. So this one looks kind of crazy, but nonetheless, I got my spiral. So for the sake of time, I wasn't able to go much further, but I want to show you the one I made earlier. I had a little bit more time on my hands, and it looks kind of crazy on the camera. Let me see if I can turn it over. So I'll show you. You start right here. You go around upside down on the spiral. You come here. You go on top of the snake. You do this. It's a little camel hump. Then you come around on the side, and you just start all over again. That was my roller coaster. So I made two different ones. One's a little, this is the adult one. This is the kid one. So that's kind of how it works. But if you did not finish your roller coaster, that's okay. Keep going. See if maybe you can make a spiral, or see if maybe you can make kind of like this hump right here. You can make a few of these. If you can see that, you can make these by pushing it up and putting it down. So try to figure out how. It doesn't need to be super complex, but just see how you can maybe make your own roller coaster. So don't give up on it. Maybe see if you can finish it. But I want to go back to those questions real quick before we head out. So like I said, we talked about a few things. We did our bridge activity. We did our roller coaster activity. When we did that bridge one, what shape can support more weight in the bridge? Is it a flat one or the one that's folded? Does the folded one help, or was it the flat one? So I know we kind of had different results on it too, but what do you think? Which one normally would be able to hold more weight? And think about the shape of it too. So Is it flat or is it folded? And you may be still working on your roller coaster, but the answer for it was actually folded. But I know that Javian specifically, he was able to get a lot on his flat one. And that's okay, probably because you made a really sturdy flat piece. But most of the time, a solid structure, a strong one, is the one that's folded. Think about triangles. That's a really strong shape is triangles. All right. And so who is responsible for designing bridges and making them? Who are the people that make them and design them? Is it marine biologists? Is it architects and engineers? Or is it flight attendants and pilots? What is it? All right. Yes, indeed, it is architects and engineers. Yes, those are the people that design and also the people that build. All righty. That is awesome that you were still on your first bridge, Javian. That is impressive. Please take a picture. And then also question 3 is, what things do engineers and architects look for when they build a roller coaster? Do they want it to be really tall, really loose, and then also fast? That sounds like an interesting roller coaster. Do they want it to be slow, tall, and stable? Or do they want it to be fast, safe, and stable? Think about it. When you're on a roller coaster, what do you want to happen? Do you want it to be stable or do you want it to be loose? What do you want? All righty. Give you a few more seconds. So yes, you want it to be fast. So you think about speed, you want it to be safe, and you want it to be stable. That is what you want for a roller coaster. That's what I would want if I'm going to ride on one, which has been like a long time. So hopefully we can go ride some roller coasters really soon. But yes, so thank y'all so much for your participation. And I'm sorry if you didn't get to build your roller coaster, but like I said, try to build it and try to make that loop because it'll look pretty cool. And then maybe you can also use some different materials to build yours. This one, like I said, is my adult roller coaster. It's very interesting. Maybe it's a little safer. It looks kind of crazy, but yeah, so go ahead and send your pictures to webinar@stemnola.com. We want to see the pictures. I want to see all those Legos on top of that bridge. I want to see how strong your structures were. And then also even if they collapse, and then also see your roller coaster. So remember, send it to webinar@stemnola.com. And then next week on the 4th, it is going to be environmental science. So get ready and get prepared. It might get a little messy. Who knows? But thank y'all so much. Have a great, wonderful day and a great week.